Okay, welcome everyone to the week 11. Today we are gonna work on the chapter 15, which is related to the all descriptive statistical techniques, how we can produce them through the SAS coding. So we already had some info regarding the statistical stuff. Today we are gonna go through them more deep, and then today we are gonna learn some statistical tests that probably you already have heard, like a chi-square, like a those kinds of correlate test. Next session, next one, we're gonna learn about the t-test, different type of t-test, single one, all the things. So, but today we are gonna go through the first two of the uh, function that we already worked a lot, the prog mean and the prog frag, but we will learn more details about it. Okay, and I will promise to just finish the class as soon as possible that you can have some fun with your family for tonight. So far we know that we have two type of category, two type of variable. We have like a quantitative variable, which we call it as numeric, and also those type of character-based tests, which we call them also categorical variables. So for the first one, for the like a quantitative one, we always use the prog mean function. The prog mean we know already that gives us some specific information, like as average, like a median, like a mode. We are gonna learn today how many more we can add to prog mean in order to give us more more statistical result. Then for the prog frag, that we know that when you are going to deal with the categorical variable, like I don't know the for example the group of the GPA, different type of group for the GPA, or for example if you want to deal, for example, with the gender, if you want to deal, for example, with some specific data set related to the type of different appliance. So that's the type of things that we can always use like a categorical section. We can use a prog frag. But what we are also going to learn today is about some statistical tests. We want to know that, for example, in a database, in a data set that we have, for example, factor X and factor Y, are those significantly related to each other, or they are not related to each other? We have to do it with the statistical techniques in order to prove that, okay, these two specific factors, for example, the weight and the height of the person, there is a correlation between these two, but we have to, for sure, statistically prove it. So we have different type of statistical tests. As I mentioned today, we are going to learn two of them. The rest is going to be later. The t-test, the ANOVA test, analysis of variance test, is going to be for the later. But today, again, chi-square and also Pearson is going to be the one that we are going to learn today. So this is so important because, for example, in a data set that you have, sometimes you want to see which specific variable have impact in the other variables. And sometimes you think there is a relation between this, so there is a correlation between these two. But when you do the statistical test, you will see no, this is probably just by chance and by luck. There is no statistical proof for it. So again, prog means prog summary, the one that we already know about all of them. But let's go through the prog means and see what we can have more from the prog mean. So you already know about the like a mean, like a mode, like a median. So all of things, standard deviation, all those things that we can have with the prog mean, but these are not just the things that you can have with the prog mean. We'll have a table that there is a lot of different statistical factors that we can have. And for sure, we are not going to learn all of them because this is not a statistical class, but we are going to just know that, for example, if you want to run the chi-square test, this is the one that you need to use. Or if you want to, for example, do the t-test, this is the one. And then, same as always, when we go through the example, you are going to learn better. So I received some email that if it's possible in class, just wait for us to do the coding. So in that case, today I would definitely try to stay on the code in order to make sure all of you can run it on your side in order to just not someone stay behind of other students. Okay, so I will try to go a little more still through the coding for today's session. So let's go through the syntax, start coding. So you probably already have downloaded the dataset, which is the same Soulbook dataset. Just make sure to have the raw version. If you don't have the raw version, again, download it from the D2L, okay? And let's first just start. I myself, I just put it in the SAS folder on my desktop. So I'm gonna create my okay. I'm gonna just run my library, okay? So the libname Hossein library is the library that I'm creating. So let's create the library. Now, again, if I go to Explorer, so right now we can see the Hossein libraries and also Soulbooks is here. So let's just one more time see what type of variable we have in this one. We already know because this is all related to the assignment 2 especially, so you already know about all of those. So the first one, the programming data, again, the programming gives us some statistical information, but it goes through the numerical variable. If we don't want to have it for all numerical variable, okay, so in that case, we can just say, okay, just give me this specific variable. So by the variable, so do you see all, okay. So by the variable, you can exactly, for example, mention that, okay, I just want this result specifically for the cell. So if I run this, we can see, okay, right now, the default version of the proc means always give us the mean, which is the average, the standard deviation, and also the minimum and the maximum, and the number of items in the variable. But at the same time, if you want to just have some specific outcome, you can just select, for example, just show mean and the median for me. So we all know what is median, am I right? Right? Nice. So in that case, okay, it's telling us, okay, the average one is 43.24, and the median, which is the middle one, is the 44.95. So this is the different type of stuff that we can always add to the product mean function based on the need that you have, okay? For example, if you want to see if the data is skewed to the right or skewed to the left based on the right, and what we know what is the skewness. In the next session, we will learn more about the skewness and also kurtosis, but I'm just going to do a little, I'll also explain about those as well. Or for example, if you want to know the uh, standard error of mean, or for example, if you want to have the confidence interval level, so that's totally pure statistical things. So all the things that you can just easily add it. For example, for the kurtosis, which is the curve, and for the skewness, which is the AW. So those type of things that we can have. Or, for example, if you want to have the first 25 percentile of the data, the first quarter, the second quarter, the third, the last quarter of the data, all of the things you can for sure just add it to the product means as well. So all of these statistic keywords, if you just add it, you are gonna see. For example, in this one, the product mean, again, data, sold books from the Hossein library. So here we want to have the N, which is the number of data, the average, median, standard deviation, minimum, maximum, range, sum, skewness, and kurtosis. So regarding the sale price variable. So we can have all the information. So regarding the data, for example, for the normalized data, we always have something like this, like a bell shape, which technically the mean, the median, all of the things, they are almost in this area, okay? So if have it like this, so technically the data skewed to the right in this section. And also the other side as well. So if we have like the tail is more to the left, this one data is skewed more to the left side. You will see the cutoff point about those. And also if the shape of the bill, if it was like this, so this one related to the curtices. So in this case, we can say we have more outlier to the data. In this one, we can say we have more normalized version of the data. So the cutoff point is important also for this one. There are different cutoff points for it, but usually uh, between the absolute value of the 2 or -2 would be the normal one for both of them. But again, in some sources, sometimes even for the curtices, people agree about 10 as well. But I myself, I always think that the 3 is the most, 3 is the good best number, especially for the curtices. So, so for this example, the one that we have, we are seeing here, if the data skewed to the right, we are going to say this is a more like a positive skew. Okay, so the data is skewed more to the right version. And this one skewed to the left, which is we are currently negative skewness. And also, again, the curtices, it's above the 0, equal to 0, and less than the 0. So that would be, again, define the height of the bell, okay, the bell shape. So for example, for this one, if we say it's between 2 and -2, we can say, okay, the data is okay. Okay, technically, we can say it's kind of like a symmetric. It's not that much very skewed. Okay, and also for the curves, if it's again between the 2 and -2, we can say again those are a good deviation that we can have, not that much extreme height. So for this one, we can say right now the skewness is 1.03. So technically, we can say it is greater than 1, so the data is skewed to the right, but for sure is less than 2, so it is almost normal. At the same time, for the height, for the curtices, is 4.8. It's above 2. So technically, in this specific data set, we can say that, okay, there are multiple outlier for the data sets, okay? But again, for this class specifically for us, we are just here more for the data analytics section. So we are not looking for the statistical take, things to learn. So that's what we are assuming that you already know about the skewness and curves. So I try to explain them a little to you. And also in the product means if you want to have, for example, a specific number of decimal points, like you see here, there are multiple decimal point for each of the numbers. So we can just use the max, DIC max decimal to, for example, 1, 2, or whatever. So in that case, you can say, okay, in the var statement, I have the maximum decimal point for 2 or 3. So it's easy to just add it to the code, like the other part of the syntax that we can just add. So just by adding maximum decimal by 2 for the variable sale price, so we can see the exact numbers. And for sure, we know that it doesn't matter how many variables we are choosing. The normal one is going to choose all the variables. But here, for example, we can say, okay, this is the sale price, this is the cost. So technically, we are running the programming function for the sales and the cost as well. Okay, so that's the way that we can always use product means function, which is very useful. Again, when you are dealing with the numeric variables, the only way that you can have these statistical techniques is through the product means function. So do you remember what was the class statement when we are using the class statement? Hmm. Then we are trying to categorize the data. It is something similar to the bias statement. We had it. For example, in a data set that you are having different weekdays, Saturday, Sunday, blah, blah, blah. So for those, you can, for example, class your date, your result based on the day. So we can use the class statement. We can use also the bias statement. We will see the difference. But when you are using the bias statement, what is the necessary condition for it? We have to always use the product sort function first and then use the bias statement, right? So in this example that we already have something similar to this one previously, let me just go through the data set and see. So right now, again, the Soulbook data set that I have, I'm creating a new one, but I'm just overwriting on that one. So not a new name, just the normal Soulbook data set, okay? So in this one, we know that we have the date function, date column in the data set. So with the weekday function, I am just trying to extract the number of days. Nothing new. We have already done this one before. Okay, and then we learn about the formatting stuff that we can create our own format, right? So what was the function for it? Product format. The value is the day name. Day name is the format name, and one is blah Sunday to Monday, and the rest and run, and then you can apply it just easily by again creating a new one, which I am again overwriting on the previous one, and the day number, the column name, the format name is day name, which is I have to put the dot as well. So if it's a numeric, if it's a character, we should always put the dollar sign as well. We know that. And then at the end, running the product means this time class by day number, variable sale price. So if I just run these first three. So right now, if I again go to the Explorer, so right now we can see that first, this is exactly like a assignment two. We have the day number here. So right now, I want to run the analysis, the product mean function on the sale price based on the day. So I'm trying to classify based on the day. So in that case, I can see, okay, for the Monday, 697 observation, and the maximum and the minimum of the value for the sale is 86.25, and the rest for Saturday, for example, almost is the highest one that we purchase something, and also the value, everything is here. So technically, we are categorizing based on the class statement, right? The buy is almost similar. Again, we have to do the product sort, but the way that bias statements show us the output, it's a little different from this one, okay? We will see the difference between these two. So this is the class version. So for the buy, as we know, we have to definitely sort it first, but let's go through the bias statement. So here, right now, the sold books is already, the day number is already set. So Saturday, Sunday, everything is set already because we are working on the previous one. So right now, we are first sorting it and then running the product mean function on the Hossein library, sold books data by day number. In this time, instead of class, we are using by, and the variable is the sale price. So if I run it, here we can see instead of having all in one table, that's the difference between the by and the class statement. There are other differences we will see, but the main one is the way that it shows in the output, in the report. So technically here we can see the start from the Monday and all the days are here, okay? So that's why we have different formatting when we are using the bias statement. The thing is, the difference between these two, again, when we are using a class statement, we don't need to sort it. That's the main difference. For the bias statement, we should for sure use the sort statement in advance. And then for class statement, we are more use it for the categorical version, categorical data. And for the bias statement, we can use for categorical and also the numerical. And also for the efficiency part, for the CPU version, so technically class statement is faster than the bias state. So that's also one of the things that when you're dealing with the big data sets, it really matters. Okay. Any questions so far? Good. Have you all had the chocolate? You want to have chocolate? Let's try to, yeah. Andy. And for those of you that came new, you missed this part. I had this one when I came, and we took the selfie for posting on LinkedIn. So that was all related to the product means. So technically, all we need to know about the product means right now, we know it. Even again, different type of specific statistical tests that we can add it. All the things that we need to have, we can just always go through that tables. And again, if you go through the books, there are all more details are here. So if you want to, especially for going for the final, like a certification exam, make sure definitely go through the book as well. But for the product break, again, similar to the product means, but specifically for categorical data. Okay. So technically, the standard version is the one-way version. You can just have a table for one. But we saw in the last week section that we can have two variables, like for example, I don't know, the days and asterisks. For example, I don't know, the profit category. We can just divide the table in these two specific variable and see, for example, in which day we have more profit. Okay, so that's sort of we set as a contingent value, contingent table. So we will run those here as well. So let's go through the book. Sorry, the codes. So again, related to the store type that we have already done it, but let's do it again. So the first one, anyone remember what was the first one? Option format search, Hossein. Oh, you know it. It just 2 weeks passed. 2 weeks passed. What was the first one? Options format search, Hossein. So when we create the custom format, where it's gonna save in our SAS, what was the custom format? Don't make me disappointed. What was the custom format? We just created one custom format together. This is the custom format, guys. This is the one custom format that we created. For example, if you see one, put it Sunday. If you see two, put it Monday. Okay, that's the custom format. Something ring a bell, huh? In your okay, good. So custom format. When we creating custom format, what's gonna happen? We have to save it, right? Remember that we said that the normal one is gonna save into the work library, but we save it into the whatever library that we are assigning. So technically, right now, if I go to the whatever format that you're creating, so you can save it all in the specific place that you want. So let me, so right now, since we just saved it in the normal library, which saved it into the work library. So this is the format. Bless you. So just 2 weeks passed. Please study. Okay? Just don't put it week by week. Make sure to definitely watch the recorded video later, or again, just go through the PowerPoint. The PowerPoint itself, I would say, is more than enough. As you see, all of the slides that specifically have coding, the next slide have a specifically line by line explanation of each line of the code. Okay, so let me go back. If I'm saying something that probably you don't remember it or something, just let me know. I'm assuming that you already know about the formatting because we did 2 weeks ago. Or right now, I'm assuming that all of you watched the last week video, which we went through the descriptive statistics. Okay, that's why I'm just going a little fast on this. Otherwise, it doesn't matter. I mean, it's nothing more than if you haven't watched it, it's okay. Just let me know. At this I can explain. Okay, because at the end of the day, this is a hybrid session. This is a hybrid class. There's a possibility that for whatever reason you couldn't watch last week video. So here this week you can just ask whatever question you have from the online section. Okay. So option format search, we are saying that okay, when I am searching for a specific format, go through the place that I saved it. Here, for example, I am just saving it into the library Hossein. In the previous one, I didn't mention any library. I just used the Prague format. When you are using Prague format alone, you are going to save your format into the work library. But here, we are saying that, okay, Prague format, library, Hossein, I'm saving the Hossein. That's fine. I'm just saying that, okay, just go and search in the Hossein library. Go and search in your specific library, okay? So the value is the categorical. So we have to use the $sign. We are naming it as a store type. The store type is the format name that we are just creating. So uppercase, lowercase, whatever version of the yes, and also uppercase, lowercase, whatever version of the no and n. So technically, we are saying, okay, whenever you see uppercase Y, uppercase yes, and the rest, and also lowercase y, put it as a store, and the same, put it as the internet. And if whatever is except these two group, just make sure to name them as a miss one. So right now I am just creating this specific format. Again, if I go right now to the my library, we can see store type is here. Okay. For example, that's a type of question that you will see in those type of SAS formatting. It's gonna ask you question even from this one. That would say, okay, what does it mean by, for example, the length 8? What does it mean by length 8? Character where? Shows. Okay, nice, good. So the minimum and also the format type, everything. When it says $sign, again, it's like a character, so you know. Okay, nice. So then the next step, when we have the format, we have to apply it. We can just apply it in a proc print function, which by proc print function, what we are doing, we are just showing something. We are not creating something, right? But when we use the data set function type, we are creating. So here we are creating again, Hossein library, we are creating sold books. Again, we are overwriting it. And format is the store, the one that we just created here. Sorry, the column name is a store. And the store type is the formats of the name of the format that we just create. So right now, again, now if I go here, we can see the store right now is store internet. And also we have miss one as well. So in that case, we can like categorize the outcome with table statement. Okay. So right now, proc frec data is sold book in the Hossein and table it based on the store. So if I run it, it's gonna give us the table that categorized based on the store. So we can see, for example, the amount of the items that we sold in this specific business, the majority of them is related to the online version, related to the internet order. So 40% of them is related to internet order, and also the cumulative frequency and also the cumulative percent is available here. So that's type of information we can have by product freak. But for the product freak, it's interesting when it's gonna be more useful when you are, for example, dealing with two different variables. And in that case, you can see the table. In the table, you can get extra information based on the two different variables, okay? So these are the things that you can have from the product freak. So as you mentioned again, the normal version, we call it as a one-way, but the two-way table, for example, here, store type, which is the one column, and for example, profit category. If it's above 50 high, less than 50, greater than 30 medium, and also less than 30 low. So technically with these two, we can also have some more useful information. For sure, the condition is both of them should be like categorical based first, and then we will see the different version of that. So right now, let's go through this part. Don't copy and paste this part on your side and run all of this part on your side first. And tell me what we are doing. Again, the codes are here. But if it's possible, just don't copy and paste. Oh, I forgot to say, also your name badge is ready. It's with Milena and Tanya. Whenever you have time, just take them later, probably next session, and ask them to give you your badge name. So what we are doing in the first part, we are creating a new data set, which already, again, we are overwriting. And then what is going to be new in the new data set? Profit. We are creating profit. So run it on your side, please. And what is the next condition? We are categorizing. So this is one way to categorize. What was the another way to categorize this data? Nope. By exactly like this: low profit, medium profit, high profit. How we could do it? Formatting, which means first we just creating through the first three lines, adding the profit column to the new data sets, and then go in somewhere else and create a custom format. For the custom format, it would say, okay, for example, if profit is between this and this low, I will less than this low, between this and this medium, and the rest is gonna be high, and then apply the format. Okay. Again, there is some advantage for this one, some advantage for that one. This is faster. You can just do it all in one place. But in that case, you can have like a custom format that you can always use it in whatever data that you want. And at the same time, you can just easily modify it based on the new data set and again apply. So in both of them, it's gonna be some positive point, but again, it depends on the way that we are doing. So let me first create the data on myself. All of you created? Yes? Yes. Okay, nice. Let me go. So right now we have the profit category. So technically profit category is a categorical variable, right? And also the store type is also another categorical variable. So we can, for example, right now do some analysis based on these two groups. Okay. So that's why we call it as a two-way table, or those type of, we call it as a contingency table. That's the one that we, again, I assume that you uh, been through the last session material. Okay, it was there. So in that case, the way that you can do the analysis based on these two is using one variable name asterisk the other variable name, both like a categorical version. Okay, so in that case, at this point, don't run the CHISQ, which is the chi-square. Don't run it. Just run the let me, okay. So read this one for me. Give me what type of information you can have from this. So first, what are these four numbers in each cell? Yeah, for example, those 9, 0 0.13, 0 0.32, 34.62. Frequency percent, and the row percent, and the column percent, okay? So we can just remove those in the code and just have some of them. And just keep, for example, just give me the frequency and the percent. It's for sure easier and it's more clean to understand, okay? So, for example, tell me right now, uh, between the store sold items that we sold, which group has the highest number? Low profit, medium profit, and a high profit. Yes. So technically, the amount that we are selling in the store, they more have like a medium profit, right? Okay. And the same for the internet is almost the same. But we can say, okay, the number of items that we sell on the internet, the number of those that have the low profit is more than technically all of the other groups, even more than the store, even more than this one. So technically, again, based on the job you are doing, it doesn't matter if it's the healthcare data, whatever data, you can just get analysis based on those. You can just have some insight out of the data set. Again, it could be from both sides. Some people ask you, for example, in different type of a store, which one has the highest profit. But at the same time, you can also come with your idea. Okay, I'm just being honest. This is the what I can do the report out of this data. So that's how the data analytics in general works. So you can just go through data, try to find as much as you can. Okay. We talked in this class the difference between the data analytics and data scientist. Am I right? No. Do you know what's the difference between the data analytics people and data scientist people? Any idea? Huh? No, it's not joke. There are, yes, please. Which one? Uh-huh. Exactly. Data analytics exactly goes through the data and just describing what's happening. Okay, just give some current report. The data scientist job, they are more dealing with predicting, finding patterns, and then predicting what's going to happen according to the current data set. So technically, data scientist people, they are more dealing with more statistical techniques. The statistics is, I mean, they are crazy in the statistics because all the things should be just based on the probability that you are predicting the future. Okay, and for sure we know which one have a higher pay. Huh? Even the from name is obvious, scientist people. Yeah. But right now, just in the healthcare area, based on what I'm just seeing, especially in these couple of months that dealing with these industry people more, I can say just with some analytical tools, whatever, Python or SAS, and also at the same time knowing Excel, which is so important. Excel is so important, guys. Excel, I would say Microsoft itself at the very first one didn't have any idea of what type of product they created. Excel is crazy. I mean, you can do anything in Excel, anything, whatever you can imagine, what analytics you can do with Excel, especially if you know which another skill, the Visual Basic. So you can just do a lot of queries with the Visual Basic in Excel. It's crazy. But plus, for example, like a Tableau or Power BI, those type of things, these three things together, they could be a very good fundamental for the people that could be like a data analyst. And the part of the healthcare that is interesting to me, if you are gonna be a data analytics person in like a high tech company, it's crazy. But in the healthcare, I mean, the level of expertise for those people should be in the moon. But for the healthcare, is not that much crazy. Especially the number of people that in the healthcare area have the knowledge about the informatics stuff is not that much as the normal people that go through the, I don't know, for example, Amazon or Meta or some type of company. That's why I believe this specific program, now I'm just advertising, but you are in the program, so you know it already. So it's exactly change the career, especially for those of people that they are in the bedside. Now they are both more through the administrative side of the healthcare industry. So again, that's the type of the uh, two-way table that we are doing. So mm, now let's just go back. Oh, before, no, no, let's first go through the tree version and then we'll go through the chi-square test, okay? So mm, yeah, before going, let's just skip this couple of slides. Uh, mhm. So in this case, we can have more than two variables. So here we just had like a profit category and also a store type. But at the same time, you can have three different variables. So in that case, the example that we have here, we are just skipping to the chunk 8. Okay, so let's just uh, mm, we will run this chi-square later. So we can here say, okay, right now we were talking about the store type and the profit category, and there was a pay type as well in the data set. So when we are dealing all of these in the three variables in a row, okay, so the first variable it's gonna be like a control variable. So technically, split the table based on the first variable, the one that is first. So right now, technically, we're assuming that the data is gonna split between the inner store, the internet version, and also the missing one. Okay, and the second and the third one is gonna be those two items that you are gonna have it in a cross version in the table. So right now, if I run it, yeah, we are just saying that just give us percent and also the frequency. Here we just have the frequency. So technically, we can see the first table is related to just internet, store, and also the miss one. So technically, the first one is going to be control variable. And right now, we are categorizing between the different type of category of the profit and also the pay type. Okay. So for example, here we can say that the pay type one has the highest number of the items that we sold and also has the most medium profit version. So that's also another way that we can run it, the three variables together. Okay. So again, based on the case that you are doing, you can just define which one is going to be the control variable. For example, here we could say, okay, I want to just have a table based on the different level of profits and then do the asterisk version between the store type and also the pay type, for example. But again, it should be meaningful. I mean, again, that's why it depends on the job that you are doing. It should be meaningful. Okay, but let's go through this part, the chi-square test. Okay, so technically, the chi-square test again, it's a statistical test. What chi-square, what ANOVA, what t-test, what those type of Pearson that we are gonna see, what they do for us, they are again checking some specific variable. Do they have specific meaningful relationship between each other? Are they impacting on each other? Or it just, for example, just some number? Because again, it matters. So for example, for the regression, we are exactly doing the same. We have some independent variable and one dependent variable. We want to see how these independent variable could impact that final version dependent variable. That's how the regression, the linear regression works. We are gonna, for example, in a normal example, let's say the dependent variable is I want to go out today. One variable is if I have free time. One variable is if weather is good. One variable is, for example, if I have money to go out. Okay. So you can collect data from the people to see, for example, you go out if the weather is rainy. So that's a very research based. So most likely to most unlikely. So you can ask questions from the people and collect the data. Doesn't matter, forget that part. Based on the data that you are doing, you can do the analysis. And then based on the analysis, you are doing the weather type, the free time, and my financial status could impact me, for example, to go dinner tonight. Okay, so change the dependent variable to the dinner tonight. So we can see by analysis, simple, even with the Excel, you don't believe me. You are gonna see, okay, this specific variable is significantly related, significantly predict my tonight's dinner. If I have enough money, that's obvious example, I would go. So technically, there is a probably significant relationship between my financial status and also my having fun tonight or having date tonight. Dinner plans, yes. Or the weather quality is also important. So there's that simple example. Just want to tell you that what we are doing in the statistical things, we are gonna see, we are gonna check are specific factors impacting each other or not impacting each other? Next session, you are going to see the t-test, specifically between the categorical variable and numeric variable. Today, the chi-square, we are dealing it when you are having two categorical variables, okay? And this one, the oh, the other one is also gonna be in the T1, yeah. So that one, the correct Pearson is for the just a numeric variable, okay? Today, again, chi-square is gonna be just for the categorical variable. And when we have multiple type of variable, categorical, numerical, we will see. This is not today. I'm just telling the future. We are gonna do it with the analysis of variance, ANOVA test. That's also another different type of test, okay? So right now with this chi-square test, first of all, if you are doing the chi-square with hand, that would be a very long mathematical step. Thanks to technology now, we can just write and say CHISQ, and it's gonna do the chi-square test for us. So in this specific example, we are doing some statistical tests to see if the store type could meaningfully impact on the profit category. That's a reasonable question. I want to see if I sell in a store or online, does it really related? Does it really impact my profit? If yes, I would probably change my policy in my job. I would probably, if I see, okay, right now, if I say online, I will have more profit, let's just close the store and just go, or not just close, make sure to focus more on the online version. So that's how the statistical things help us. That's how the statistical techniques help our data scientists to predict the future. These are the very simple examples. They are doing all the Bayesian, all this stuff, very crazy things that I myself, I have no idea what they're doing in some scale. So again, for this example, let's run the step 2 on the chunk 7 again, and this time with the chi-square and the no column. So right now, we will see the chi-square value 7.06, and the p-value, the probability is 0.13. So by next week, you will have better understanding of the hypothesis testing. But any of you in this class remember what was the hypothesis testing? H null and H1. You told me that you all been through the statistical course before. Null hypothesis. You remember what was it? Yeah, null and yeah. So let's see. Again, next week session, you're gonna have all of them in details. But let's. So we have this, we call it as a null hypothesis, alternative hypothesis. Remember that? Down backwards. Okay, let's repeat to the. Okay, so we are assuming, for example, it doesn't matter what is X, it doesn't matter what is Y. Okay? Okay. So technically, we always do the in the alternative one, we are assuming X is equal Y. In the null, we are assuming X not equal Y. Okay, so that's like a base assumption. I'm assuming X is not equal to Y. So with whatever statistical techniques, I do statistical things like the chi-square, and at the end, I will receive some probability value. Okay, so if this probability value is greater than p-value, which p-value is 0.0, 0.5. It could be 0.1 as well, but this one is the more conservative version. Again, where this one come from in a data set, this part is 90%, this side is 5%, 5%. Whatever inside this, we're gonna accept. Again, this is not a statistical class, I'm just reviewing it. Okay, so in that specific example, we are assuming the store type impact on profit. So the null hypothesis will be a store type is not related to the categorical profit category, and for this one we are assuming is related. So the probability over there is 0.13, right? So 0.13 is greater than 0.5, which means we don't have reason to reject this null hypothesis. If the whatever probability would be less than 0.5, we have enough reason to reject this one and accept this one. So in that example, we don't have enough statistical reason, evidence to say, okay, store type have impact on the profit category. Okay, so that's the whole. Was it the same that you learned, or kinds of the same? Okay, so in this case, let's go through the PowerPoint again. The PowerPoint itself is enough. So the null hypothesis here, we are saying that there is no association between the two categorical variables. They are independent. X is not equal to Y. I'm just trying to make it easier, equal or not equal. You will see in the next week section that we are gonna deal with the less than, greater than, all different type of the null and alternative hypothesis test. So the alternative one, which means they have the significant association. If I could prove it with the statistical testing, I would say, okay, there is a significant association, significant correlation between the store type and the profit. In that case, I can evidently talk, okay, right now there is a significant relationship between these two. So if I am saying that, okay, if we are supposed to go with the online version, we are going to have more profit. This is the proof by science, by mathematics, by statistics. Okay. So right now here again, the chi-square is 7.06, and the p-value is 0.13, which is greater than 0.05, which is the common significant level, or p level, the p-value that you're saying. So since the p-value is greater than 0.05, we fail to reject null hypothesis. What was the null hypothesis? There is no association. When we fail to reject this, which means there is no association. Okay? Right, sorry? Yeah, so technically by failing to reject, which means you have to accept it. Yes, you are failing to, that's the part. I mean, technically you are assuming always there is no connection. That's going to be a null hypothesis. You are assuming these two are not equal. That's a null. In a t-test, you will see the mean of one group and mean of the other group. You're assuming the means are not equal. In the alternative, you're assuming the means are equal. Then, based on the test, the probability value is going to be whatever. Now it comes less than 0.05. So technically, I can reject the null hypothesis and accept the alternative hypothesis. If it's greater than 0.05, I technically fail to reject the null hypothesis. So in this one, there is no significant, meaningful relationship between these two groups. Okay? Let me show you something. Maybe I will also record this one because uh, it also makes sense. Why not? Let me. Mm, so this is one paper that I published. Let me show you something. I just want to give you better understanding. So I did the analysis on social media using from some perspective that we call perspective of commitment. We did some research in 2022 that we found almost 64% of our respondents, they always wanted to leave social media, but they were always using it. Okay, that's like a paradox. Okay, so the idea came from myself because I used to delete Instagram for 2 weeks and again come back to Instagram for 2 months. That's a lot of love-hate relationship. It doesn't matter. That's the idea of the paper that came. We published it in 22. So the things that those things that I showed you, I mean, I told you my plan for tonight, like a dinner, depends on the weather condition, my financial status, and also what was the other, free time or whatever. Okay. So here we are assuming that dependent variable is continue using the social media. Okay. I said having dinner tonight, here continue using it. So what factor impact on it? Perceived enjoyment. I enjoy it, I use it. Because of a learning perspective, I am using it because of a learning. There's a positive relationship. Then because of the FOMO, I might think I'm missing something. So that's why I'm using it. And this one, you don't believe it, this one is the most significant factor that people are using social media because they are thinking they are missing something if they just delete the social media. And the last one, privacy concern. Because of the privacy, I might not use it. Again, factor doesn't matter. The things that I want you to just understand it. That regression that I told you, this is like an advanced level. We call it PLS method, partial least square, blah, blah. Okay. So at the end, we came out with this one that, okay, for example, technically privacy concern, even though it is significant, even though it has impact, but it is very low, just 0.09. But for example, the FOMO has 0.08, 0.28. So 28% off. Just pay attention to this one. Again, this is not our course. I like to see, I like to tell you the information. Technically, that continue using 28% of it justified just because of the fear of missing out. Okay, so that's a coefficient. That's in a regression we are saying that 20%, 28% of it impact on the dependent variable. Dependent variable, which means the one in the end. Independent, they are not dependent on anything. They are impacting. Okay, so the same here. Here we are doing what is it? We are doing the chi-square again to see some specific factor impacting on each other or doesn't impact on each other. Okay. Exactly. Yeah, there is a famous example. I always forget this example. In a summer, people they might say number of people that they just die in the sea when they are swimming. They draw. What we call it? Draw. You draw on the sea. It's related to the number of ice cream that's melting. Technically, the numbers are related. But statistically, when you do the analysis, it's not related. That's because of the consequence. Because it's summer, stream are melting. Sorry? Yeah, exactly. So that's the thing. If sometimes numbers, it seems they are related, they are not always related. You have to always prove it with the statistical technique. Okay. So in this case, we can say, okay, right now, we might at the very first moment say, okay, probably there is some relationship between the category of the profit and the store type. But statistics telling us no, there is no relationship. Okay. There is no meaningful relationship. There is no significant relationship that you can make a decision based on those. Okay. So oh, yeah, I was saying we had this one. That's why I just surprised. Where is this one? So we talked it for two categorical. We are always using chi-square. Okay. So when the variables are categorical, we are using chi-square. When the variables are numerical, we are using this specific Pearson correlation coefficient. That's the same. Just the function is proc, C-O-R-R, proc core. Okay, so proc core, here we are just doing analysis based on the one. Make sure to run it on your side because I want to see the result. We have the hard data set in the SAS help menu, SAS help library, right? So just make sure to write these three lines, please. Proc correlation, proc CORR. The data is SAS help library. Testing, testing. Just Okay, so when we run it, we can see right now we are dealing with two numerical variables, okay? So which is the weight and the height. So that's a normal information we can have. And here we can see between the weight and height. So right now the probability that the value is less than 0.001, which means less than 0.05. So right now in this specific example, uh, what is the null hypothesis and also what is the alternative one between the weight and height? Okay, what is the null hypothesis? We are always assuming there is no relationship, there is no correlation. So here the null hypothesis is going to be there is no significant association between the x and y. There is significant association between x and y. What is the probability is less than whatever it is less than 0.05. So which means we have enough evidence to reject null hypothesis. So we accept alternative one. So which means we are saying that we can reject this one. We are gonna accept that there is a significant relationship between the weight and height. And what was the relationship number coefficient? 0.51, right? So technically, again, whatever I just discussed, all here. So for this one, there is a 3 cutoff points. So this correlation, Pearson correlation is between -1 and +1, okay? So if it is kind of less than 0.10, weak, 0.30, moderate, greater than 0.5, strong correlation. So in this case, we have 51, so we can say there is a strong relationship between the height of the people and also the weight of the people, which is obvious, okay? So that's it. So let's go to the so the data set that we have here again is technically one data set for the female, one data set for male, and also the additional. So 3 data set that we have here and the column for each unique ID, the ID, the sex, GPA, and also how important student feels religion in their life, and also the missed class number of classes student report missing in a typical week, and also usual classroom seat for a student, front, middle, back. So 3 categories for this 3 group, okay? And also the same for the rest. So the first one, importing, which for sure we all know how to import these, and just make sure when you are importing for the male group, just name it as a male. For the female, name it as a female, and also for the additional, name it as an additional in whatever library that you are working, okay? And then the second one, concatenate the male and female data into the new data set. So again, yes, 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 yes. Concatenate the males and female data into the new data set. So I think 3 weeks ago, session was related to the merging and concatenate all the things. So we just know that the function for it is like a data set, data, whatever new outcome that you are creating, the set version, and the set, you have to say the male version in the whatever library you have, and also the female version in whatever library you have, and just run it. So technically, in that case, you are concatenating these two data sets, okay? Exact coding are in uh, 3 weeks ago before the formatting session. That was one of those online sessions that we had. Was related to all merging, concatenating everything. All the code was there. So the number C, merge the additional information onto the student's data and set using the variable ID as the key. Technically, you are just adding the additional data sets to the one that you just created as a concatenated one. You can name it students or whatever. I name it students, and then this time you have to merge the additional one, okay? But when you're doing a merging, you have to mention by which one, by ID column, okay? But again, when we are using the by version, we have to first sort it. So you have to sort the student version at first. You have to sort the additional version by ID first, and then data, whatever new one that you are creating, and the merge function. The merge function could be the students that you just created in the concatenate one, plus the additional. Just don't forget to mention that, for example, a student in equal A, that one equal to B. Exactly, we had exactly similar to this one, just different context in that PowerPoint. So I'm not just gonna again go through them detail. So number D, create a new variable called adjusted GPA, that is GPA reported in the file minus the average GPA, okay? So technically, you can just create a new data set, whatever it is, and you have to have the new column. The new column name is adjusted GPA, which is equal to GPA minus the average one. How can you have the average one? Sorry. That the easiest one, I would say, just go to proc means. I mean, having the proc means for the data set that you have and variable GPA. So the number is 3.17. The number is 3.1792140. You have to reach this number, okay? Create another variable, the Evers. Create another variable called the letter grade that reports A if the GPA is above 33.5 or higher, B is between 2.5 and 3.5, C greater than and equal to 1.5 but less than 2.5, and D based on the new condition. So again, for this one, you can do it in two ways. One, creating like a formatting stuff, but I would just use it through the data set function. Data, the whatever output, set whatever input you have, and then if GPA greater than 3.5, then the letter grade A. else if, else if, else if, until the last one, else letter grade is F, and just end. Okay. So number 2. Number 2. Using the data sets from question 1, complete the following exercise. Report the average and standard deviation of the variable adjusted GPA. The one that you created, the adjusted GPA. So you have to just run the proc means for that data set, select the variable adjusted GPA, the one that you created. And for that one, just make sure to have the mean, standard deviation, and the max DEC to 2. Okay. Calculate the percentage of the students that respond to each level of the questions, religious importance. So what percentage of the students feel religion is very important? So technically, you can do just by easily proc frequent of the data and just having the table based on the religious importance. So you can see the exactly percentage for that. Calculate the percentage of the female students who sit in front row and compare it with the percentage of male sit in the front row. So we are dealing with how many variables? We are dealing with the sex of the variable, sex variables, and also the where they sit, the sit front, those 3 categories. So technically, we have to have the contingency variable. So proc frec, and then the sex asterisk by seat the table, and just please don't put that, don't put the screenshot of the table for me. I want to know that you can read the numbers from the table. Make sure that, okay, this is the percentage of the, for example, what is it? The male in the front row in comparison with the female in the front row. Just don't put just a screenshot. Show me which number we are talking about in the table. The other way for this one, we can just easily, for example, also, instead of this, we can first sort it, for example, by sex and table it by seat. I mean, table seat by sex. That's also another way. Both work. Calculate the percentage of the student that miss 0 classes, 1 to 3 classes, or more than 3 classes. So technically, just a normal proc frec tabling based on the miss class variable. And forget the EF, you can think about it. Then question 3. Calculate the average GPA for males and females using appropriate procedure. How? For sure, you need to use the proc means. You might probably like categorize it by sex. So let's first sort it by sex, and then proc means variable is GPA, and also by sex. Get a 5-number summary for the adjusted GPA, Q1, median, Q3, mean, max, all the things that you need to just give all the answer. Proc means you need to put all those specific quartile into the proc mean function for the adjusted GPA. And then creating the histogram, which we have to use which function for it, for those of you that watched the last week video. G bar, G chart, proc G chart. So the data is those merged one, the one that you are merged in, and the H bar is the histogram, based on the GPA, and also it mentioned type should be percent. The pie chart, the same code, just instead of H bar, just use the pi version for the seat selection for sure. And again, bar chart, V bar is the one. This time for the religious IMP. And the last one, just you think about. Any question?